Question, f of x equal to x plus 5 all over what? Square root 9 minus what? X squared, right? Okay, so let us see how we attack this question. Clearly, we know the condition we apply to the numerator. We had explained if you have radical function in the numerator, set it to be greater than or equal to what? 0. So we don't need to express ourselves there anymore. Hit it straight on. An example, you know you are setting this x plus 5 to be greater than or equal to 0. If we do that, we get x to be greater than or equal to minus what? Correct. Let us visit the denominator now, right? In the denominator, again, we are not going to waste our time on it. Yesterday, we had already established a shortcut of attacking that question, right? Find square root of this, right? If you find square root of 9, what will you get? Plus or minus 3 rather. I hope you're following. Now the problem here now is, how do we present this for the value of x? Because we are going to write x either greater than or equal to something, then x either less than or equal to something, true or false. But because this term, this radical is in the denominator, do you think you are going to use equal to? Would you use equal to? No. If you remember, there was one question we saw, and we explained that when radical function is in the denominator, the fastest approach to it is to set that term inside the square root to be greater than 0. No need of putting equal to. That was what we agreed upon, right? So in that case, it means for us to write the value of x using this plus 3 and minus 3, we are not going to use anything like equal to them. Are you getting me right? It's either greater than or what? Less than. Am I making sense? Yes. The question now is, you have two values here, plus 3 and minus 3. Which one will carry less than? And which one will carry what? Greater than. I just explained that already because the number appeared before the what? Alphabet square. It means that the guy that is going to be greater than here will be the smaller number. So in this case, it implies that x is greater than minus what? Or x is less than what? I hope you are following, right? At this point, you are done solving for the numerator condition and the denominator condition. The numerator condition told us that x is greater than or equal to what? Minus 5. And in the denominator, x is greater than minus 3, or what? Less than plus 3. Like I said, sometimes it might be a bit tough for students to interpret this and get the domain. But one thing I've found very interesting to use is the number what? Line. But although you can still look at this, and if you can work it out quickly, at heart, fine. Imagine that you are dealing with numbers that are greater than or equal to what? Minus 5. Can we think of such number? You will start from minus 5, is that not so? You move to what? Minus 4. You move to what? Minus 3. You move to what? Did you take note that as we are moving from minus 5, increasing towards positive infinity, are you getting me? You met minus 3, true or false? Permit me to use this word. Minus 5 jumped minus 3 from behind. True or false? Minus 5 is moving. It now linked up with what? Minus 3. Which means that the actual range or domain, if I am to consider minus 3 and minus 5, since both of them appear greater than, are you getting me right? The actual range or domain respecting these two guys will be from minus what? 3. Will be from minus what? 3. Because the range of this minus 5 linked, attached, jammed that of minus 3 as the value we are moving. Are you getting me right? Then, coming to this is x less than 3. X less than 3 faces this direction. Am I correct? And the concept of intersection, like I explained, the two guys will meet, move this way, and then they will hit. Is that not so? That's when you get the what? Intersection. So, all said and done. So, already, these guys, it was increasing. It met this. So, for these two guys, the answer will start from where? Minus 3. It will keep moving, increasing. But coming to x less than 3, it will do what? Stop. Because x less than 3 will now face this direction. So that all said and done, the answer of this will be minus 3 and what? Plus 3. Let me quickly show you the number line. We have something like this. Let's take this as 0. Let's take this as plus 3. Take here as minus 3. Take here as minus what? 5. Are you ready for the number line? From x less than 3. This is less than not equal to, so you don't shade. Are you getting me right? The number line is just for you to see the clear interpretation. And like I said, we just want to be honest. If you could draw the number line faster, you can easily answer the question correctly. Are you getting me right? Than going to overstress your brain counter and this one jump the other one. If you draw the number line, you'll be seeing it clearly. Are you following? So we have that of minus 3. Minus 3 started from here, going this way. As these two guys are coming towards each other, they will intersect, right? And the intersection is the domain, isn't it? Yes. Okay. Now let us draw that of x greater than or equal to 5. It will take this form and go this direction. It will keep going. It can go to infinity. Are you following, right? However, what I'm trying to say is that this number line for x less than 3 will not allow this x greater than minus 5 to cross. Are you getting me right? Because it will stop it there. Why? If this number line continues after here, is there anything to intersect with here again? No. So as this x greater than minus 5 is increasing, the limit has been imposed on it by this what? Plus 3. So this is what we do now. Watch. X greater than minus 5 starts moving from here. It goes, it keeps increasing. At this point, look at it. Is there any other line that intersected with it? No. Did it meet any line? No. Where it met a line, a kind of, let's say, I use the word jamming. Are you getting me right? It's from here. Do you agree? Yes. Do you agree? Good. Which means this x greater than minus 5 started its first intersection from this point. Do you get that right? Because this line intersected with this line here, although both of them are moving in the same what? Direction. That is why you just pick the value of minus 3 from here for both of them. At this point, look at from here backward, there is no intersection. Are you getting me right? No intersection. Now, coming to this point, the intersection we are talking about, since both of them are facing the same direction, as that of greater than minus 5 was moving, it linked up with that of minus 3, and both of them moved in the same direction. So our domain will start from this minus what? 3. Our domain will start from here? Minus 3. Because with these two guys now, from here we can just use one line to represent both of them. Do you agree? Yes, no? From this point now, both of them have the value minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, going to positive what? Infinity. So I'll quote that domain is equal to, the first point will be from minus 3. Now, this minus 3 we are starting with, what will be the bracket? Will it be square or curved? Curved. It will be curved, correct, because this thing was not shaded. Are you getting me right? Curved. Then comma. These two guys started their journey together from minus 3. They keep increasing. They will get to this point. Will they cross it? No, because this line is coming towards them. That is the proper intersection. Are you getting me right? Which means as these two guys are moving, they are not allowed to cross here. Do you get that right? Since they are closing up. The boundary will now be 3. How do you close? With which bracket? Curved. Because this minus 3 plus 3, you know, is just less than and greater than, nothing like equal to them. So this is the correct answer. This is the correct answer. That's the domain. There were some of you that quoted something, and I'd like to write that. That quotation is also correct. I'm going to write what some of you wrote when I saw that. I think I saw something like, good. If you are able to list out all the numbers between minus 5 and infinity, are you getting me right? Which is the solution of this guy? Are you aware? And you are able to list out all the number between minus 3 and what? Plus 3. Which is the solution of which part? This one. Are you getting it? If you like, you can still break it up from minus 3 to to plus infinity, then from plus 3 to negative infinity. But that is a waste of time. Both of them met. They form one answer here, isn't it? Minus 3 to plus what? 3. If you list the value here, you list the value here, check the normal set intersection, you will see that it will meet at what? Minus 3 and plus 3. That minus 3 and plus 3 will not be part of the domain. It will just form the boundary. Are you following me, right? If you actually leave the numbers out, what you will see as intersection will be minus what? 2. Am I communicating? What you would see for each of them will be minus 2. But you can't just pick that minus 2 like that. You need to form what? A boundary. Since between minus 2 and 3, there are infinite real what? Number. I hope you're aware of that. So that is the correct interpretation of this. But in your examiner will prefer to put the domain in this format instead of this. What have we learned here? The shortcut applied here, do not forget how you make use of the inequality sign. Are you getting me right? Because of the fact that you swap this, number appeared before what? Alphabet. If alphabet appeared before number, then the smaller number will carry less than, and the bigger number will carry what? Greater than. But if number appeared before the square of the alphabet, in the case of difference of 2 squared, the smaller number will carry greater than, and the bigger number will carry what? Less than. So you want to remember this when you are applying the shortcut. Alright friends, we are done with the concept of domain, having solved questions on domain of polynomial function. That one was 1 plus 1, is that not so? Domain of radical function only. That one was also pretty 1 plus 1. Then domain of rational function. Not tough, but when you now start introducing radical function in rational function, you now see that the interpretation is no longer too funny, but is it difficult? It's only tough. It just needs you to take your time, revise what we've done. Are you getting me right? Practice questions. If you have problems, like I said, I am just a DM away from you. And we have video lessons on this that you could also watch if you need further assistance. Alright, you have a question? Please supply the question, let's see. Is it from past question? Can you read it? Is it possible? Or let me have it, no problem. Just break, no problem. Question what? 1. Question 1. Okay. This is 2526. Are we ready? Please copy. During this year, the exam was subjective. Subjective means it's not theory, it is not OBJ. No option, are you getting it? Yeah, you will solve and then write just your answer there. But that is not the type of exam you are going for, so don't worry. This one you have options, are you getting it to guide you? Can I dictate the question? Right, let A equal to the set. Let A equal to the set minus 3, 2, 1. Z equal to sets of integers. Sets of integers. Integers. Let F be such that A is mapped to Z. Be defined by the function f of x equal to 2x minus 1.